Today we're talking about graphing exponential functions. So anytime you have an exponential function, guess what is in the equation? Exponents. You guys are pretty smart. All right. There are two requirements for exponential functions. The base can never equal 1. We're going to talk about why. But if you think about it, if your base is 1, if you have a 1 here, 1 to any power is going to be 1. So are you going to have any kind of line or increasing or decreasing? No, it's just going to be a flat line. So that's why you're not going to have 1 in the base. And your base needs to be greater than 0. Again, if you think about it, if you had a negative base, if you had like a negative number here and you're bringing it to a positive power. If you have a negative raised to the second power, it'd end up making a positive. But then when you go to the third power, it'd make a... So if you're thinking about graphing, you're going to have like a positive point, then a negative point, positive, negative. So your graph's going to be all over the place. There's going to be like no correlation. Do you get what I'm saying? Yes? Maybe? We'll see it here in a little bit. Okay, so when you're dealing with these, the easiest way to graph an exponential function is by plugging in values, oftentimes. So you always want to choose values for your exponent. So if you notice here, there are values for x, because x is in the exponent. Okay, so what is 3 to the second power? 9. What is 3 to the first power? 3. What is 3 to the 0? 1. Good memory. What is 3 to the negative 1? 1. You guys are amazing. And 3 to the negative 2 would be? 1. Do we notice anything, any patterns here? Yeah, so like the second power is 9, the negative second power is the reciprocal of it, 1 over 9. Okay, so now we're going to graph these. We're going to see what this graph looks like. So on the x-axis, I go over 2, up 9, which is right at the top of the graph. And then over 1, up 3, 0 up 1, negative 1 is up a third, negative 2 is up a ninth. So when you're doing those, when you're plotting like the 1/9 and 1/3, just realize it's a fraction. So it's not quite to 1, right? Which one is bigger, 1/3 or 1/9? 1/3. So this graph, if we're going like this, as your numbers get smaller, the larger negative numbers, your graph is going to end up getting closer and closer to this x-axis. Because if I had negative 3, it would end up being like 1 over 27, right? If I had negative 4, it's 1 over 81. And so it's just going to get closer and closer to the x-axis, but it will never actually touch the x-axis. Okay, so this is what happens when we have a whole number here. On our next example, we're going to see what happens when we have a fraction. Okay? No matter what number would be here, you are going to get a similar graph. So whether this is like 5, 10, 15, whatever it is that you choose, the graph is going to be similar to this. Okay? So now let's look at the fraction graph. So you have a fraction raised to an exponent. So if I have 1/5 to the second power, what will that equal? Very good. 1/5 to the first power is? Good. 1/5 to the 0 is? 1. What's going to be 1/5 to the negative 1? And 1/5 to the negative 2 would give me 25. And remember that they end up being the reciprocal of each other's, right? Okay, so let's graph them. So this one, the x is over 2, up 1/25. So again, it's not quite to 1. It's somewhere in between 0 and 1, right? Over 1, up a fifth. So again, it's not at 0, but it's not to 1. 0, 1 is right here. Negative 1, 5. And then negative 2 up 25. Let's just not even worry about that one because it's way off the chart. So if you notice, this one, the graph is going to the opposite direction. So if you have a fraction, your graph looks like this. If you have a whole number, your graph looks like this. And all of them will end up being similar. Okay? Questions so far? All right, moving on. So, with exponential functions, exponential function graphs look like this. You have to draw them in. Or this. Graphs are called decreasing. Very good. If they drop as they go from left to right. How did you know that? Oh. Graphs are called increasing if they rise. Or go up. That works as well. As they go from left to right. So again, remember how you read things from left to right? So this one, see if you're going left to right, it's increasing. See this one, if you're going left to right, you start at the left and it's going down. Make sense? All right. Okay. If the equation y equals 5 to the x power is graphed, which of the following values of x would produce a point closest to the x-axis? Now, you could do like a t-chart how I did on our previous examples, but if you just want to go back and look here, what is the graph going to look like on y equals 5 to the x? Is it going to look like my example 1 or is it going to look like my example 2? Okay, so that means this graph, would we call this an increasing graph or decreasing? Okay, so let's draw this graph over here so we have an idea of what it looks like. So it says, if this is graphed, which of the following values of x would produce a point closest to the x-axis? So which x values are getting closer to the x-axis? So as you go this direction right here, it's getting smaller and smaller. So -1 would be the correct answer. Some of you may have said that, some of you did not say that. So if I had -5 on here and -1, which one would you choose? -5. So the larger the negative number, the closer it's going to get to the x-axis. You might want to write that down. The larger the negative number, the closer it will be to the x-axis. Okay, and if you go back and look at this other example, remember 1/9 is closer to the x-axis than 1/3, right? So the bigger the negative number you plug in for x, the closer it would get to the x-axis over here. Okay? So this graph, if the equation y equals 1/3 x is graphed, which of the following values would x produce a point closest to the x-axis? So this graph, though, is going the opposite direction, right? So this graph is increasing or decreasing? Decreasing. Remember, you read from left to right. And the graph looks like that. So which value on this one do you think would produce a point closest to the x-axis? Which one is the best answer? D. Because this is really 1 3/4. Do you agree? What is so funny? Tiffany's laughing at me. Okay, so the larger the number, the closer it is to the x-axis. This is my largest number here, 1 3/4. Yes? Okay. Any questions? All right, example 5. To understand why the base has restrictions on it, we are going to see what happens if we let the base be 0. So the base is 0. What is 0 to the second power?
0, 1,
Yeah, no, you're remembering that anything to the 0 power is 1, but 0 to any power is saying 0 times 0 times 0 times 0, which means all of them will be
7.
If you were to make this line 2, 0, 1, 0, 0, 0, negative 1, 0, negative 2, 0, this is just a flat line. That doesn't give us any information. That is why your base can never be 0. So the base must never be 0, 1, or negative. And again, you'll have a chance to do this in your homework, but you'll see why that will not work. Number 6, which multiple choice ordered pair represents the y-intercept for the function? So when you are finding the y-intercept, you are plugging in 0 for what? Exactly, you will plug in 0 for x and solve for y. So when you do that, y equals 2 to the 0 power. What is anything to the 0 power? 1. Y equals 1. So therefore, my x value is 0 and my y value is 1. So the correct answer is B. Okay, select the correct multiple choice response. The graph of y equals 1/10 to the x power contains which of these points? Okay, so remember that you can plug in x and y if you wanted to each of these equations. Okay, so if I were to plug in 0 equals 1/10 to the 0 power, what is anything to the 0 power? 1. So 0 equals 1. Does that work? No, therefore A is not a correct answer. Again, this is your x and your y. 10 equals 1/10 to the 0 power. 10 equals 1. Does that work? Good, the answer is C. If you go back and look at our original graphs that we made, what do you notice about the y-intercepts on both of these graphs? The y-intercepts. They all, no matter what exponential graph you, well, it could actually be slightly different. But if you just have a number to the x power, the intercepts are always going to be at 0, 1. Do we see this? Because anything to the 0 power always equals 1. Okay. All right, any questions here? Okay.